off well.
Jackson, 1 through 6, pick a number.
4.
Hold your hand up so we remember, everybody remembers. Zabin. Parker, Logan. Zabin's already got 2.
Are you restarted?
Take a look at the fingers.
Are you double restarted?
Already got it. Brooklyn. So what's left? 3?
3, whatever.
I had 3.
Oh,
1 and 6.
all of them should be taken.
1.
5, 1, 2,
He's 6
3.
Yeah, I'm 6.
Yeah.
Okay.
years old.
4.
Yes.
Frick.
Bet you wish I had that one now.
Shut up. Oh. Okay.
Yeah, we'll, tell us what's supposed to be there. And Zabin, watch out when you convert yours. Make sure this doesn't happen.
Yep.
I'm hoping, well, I'm assuming that it's from the conversion.
Yeah.
I'm guessing it's going to happen a couple more times.
My technology was the Dremel 3D45 and 3D20 3D printers. And I don't know what's underneath that.
What happened to your thing?
I don't know.
Yeah, we just discussed this.
I didn't like where I put that battery. Next.
Is that going to work?
No.
Okay.
Wait. No.
Nothing's working for you.
There.
Oh. Okay. My challenge is to come up with my own invention or product idea. Design a draft prototype using Tinkercad, then evaluate your prototype. See if you can find ways to improve it based on what you discovered through analyzing the design. I will use Dremel 3D printer to create a DeWalt battery holder for pegboard. I will be able to design, print, and test my product within the given 4 days. I will be able to complete my goal with Tinkercad, Digilab, and the printer itself. Creating this because I was considering purchasing a 3D printer and wanted to try it out. I will meet my goal by designing it on day 1, printing it on day 2, defining it on day 3, and printing it on day 4. All the words. There's supposed to be stuff highlighted here too, but it's not. My technology is Dremel 3D20, 3D45, 3D printers. There are thousands of brands of 3D printers, and they're used for manufacturing all kinds of things for people all over the world.
Sorry.
You're good. Oh, the arrows are gone. 3D printers are used for a lot more than just printing small workshop organizers. 3D printers are even being used to build houses. That's a 3D printed house, and that's the 3D45 that I used. There were a lot of problems. The first print, I tried to pull a smaller piece of the model before the rest of it was done, and it shook the plate, and so the top half of it was unaligned from the bottom half, so that wouldn't work. Second print, the same thing happened, except I didn't try to take anything off, it just moved on its own. And I tried to fix it with the Dremel, it didn't work. The third print worked, but it was too tight for the battery, and the bottom of it was like curved up for some reason. For my technical difficulties, I learned that you should not try to remove parts of your build before it is finished. I also learned that sometimes things just go weird for no particular reason. I learned some skills that I can use with my own 3D printer, like changing the filament. On day 1, I started 3D printing and I completed my first model, and I'm hopeful that I got my measurements correct. I tried to take a smaller piece of the print off, and yeah, it shifted the top and messed it up on the first print. That was day 2. day 3, I learned how to make a negative space so I could make the drill holder out of what I already have, but it, yeah, I tried to fix that after the second print, did the same thing, and it didn't work. So I checked if my battery would fit in the final print, which it wouldn't. It was just like a little too tight. And so, yeah, and then I made it. So I printed my second model, but the top was on line with the bottom, and final model turned out right-ish, but the bottom curved up for some reason. Kind of just did that, and the battery didn't fit because it was too tight. Yeah. So, did I succeed? No. For some reason, I couldn't make this text box skinnier. Despite my efforts, I was unable to make a functional battery holder. I think that if the printer worked as expected, I would have been able to complete my project. I don't know. Yeah, I would have been able to complete the project. Oh. Oh, okay. I did not complete my SMART goal, but I was able to learn a lot about 3D printing. I was not able to create a working battery holder due to technical difficulties, but I managed my time well and was able to keep to the schedule of my SMART goal. I learned the software needed and made a 3D model successfully. Some kind of error caused the lower part of my final build to curve up. I'm curious what caused this. Overall, the project was fun, and I decided to buy my own 3D printer.
So you did actually buy one.
Yeah.
So I'm guessing your words were highlighted throughout here.
They were.
Brooklyn.
It's not.
3, 4, 5.
Can't be 4
I got
twice.
5.
Morgan's 2. Go. Morgan's 2.
Oh, you can roll it, buddy.
Yep.
You roll it,
Everybody's
buddy.
got a number. 1.
Great.
Remember, we are watching everybody else's presentations, not working on other stuff.
Do I address the elephant in the room?
When it comes up.
Okay. 3D printing, my technology was Tinkercad, and the launcher was level 2 Tinkercad prototyping.
It's not working for that either.
No.
Alright.
Holy moly.
Oh, none of. Right. Yeah.
Yeah, none of my words highlighted either.
Okay. Oh no.
So, your challenge is to come up with your own invention or product idea, design a draft prototype using Tinkercad, then evaluate your prototype. See if you can find ways to improve it based on what you discovered through analyzing the design. I will be using Tinkercad to create a Ray Blaster from the hit game Black Ops 2. Yeah, I want to be able to finish this in 4 days and all that stuff. About my technology. Technology is Tinkercad, software you can make 3D printable things or shapes that you can make, that you can print out of these shapes that you can make. Real, well, they're both real, but that's industrial and this is the one we have. That's for business and this is for education and recreation or whatever. My text box was not formatted like that, but that's okay. I learned some more things about the 3D, how the 3D printer works. I learned that you can like draw your own shape in there. That was cool. I didn't use it, but I just figured that out, I guess. I also learned how to make skinny things more strong so they wouldn't snap. Just put like another thing inside of them. Problems that I had. Biggest problem I had was getting the Ray Blaster to print without all the little parts on it breaking while taking off the supports. I printed this Ray Blaster and all the little parts broke. Also the barrel of the blaster broke off because I dropped it from like 2 inches off the desk and it hit the desk and it just exploded basically. Barrel went flying. That's why I'm holding it so awkward and tried to super glue it and work. Every time I had to print this, I had printed it in a different way to get the supports away from the skinny parts. Yeah.
Okay, I think.
Oh.
Yep, that's your conclusion, right?
Yep. I did not achieve my SMART goal because I was not able to get a successful final product. I would do this again, but I think I would want to do something different that I've not done before. I like that it gave me freedom to print whatever I wanted to. I had the success of failing a lot. I learned what something looks like when you print it on ultra quality. I haven't done that before. I will never, ever in a million years print this ever again because the design is so bad that I printed it 3 different times in 3 different ways, and all of them still broke.
Well,
So did you ever get to actually designing your own 3D or blaster? Like, was the plan?
No, like, I don't know, it was just like so complicated. Like there was, like if you like look at it, there's like so many like little parts. Like this broke off, these broke off, or like little like things. This end broke off, and there was a sight that broke off.
So this whole launcher kind of turned into a whole launcher on ways to not 3D print.
Yeah.
Things to look out for, not so much prototyping.
Pretty much.
Learn a lot.
Yeah.
alright.
What was the elephant in the room?
Like 5 slides we're missing. We got 1, 2, and 3 called for, so then Jackson, Logan are 4.
What? I already presented.
That was
Bow.
oh. Four.
Let's go.
Laser engraver part 1.5. I put 1.5, and you'll find out. Our technology, the Muse laser engraver. Our launcher, the ULS laser engraving.
Oh, so my screen's just not working good.
Broke.
Our challenge is to use the Muse laser engraver to engrave designs into objects. We'll use the Muse laser engraver to create some engravings on different objects on the laser engraver's application. This is my second time doing this launcher. I'm showing Logan how to use the app and some of its features, like importing pictures and autofocusing. Measurable. In the 4 do-it days of this project, I should have at least 4 different objects that are laser engraved, because that's what I did last time. We'll be able to complete our goal. We have all the needed resources like the laser engraver and the book from the Boat Tech Center and a partner to ask about any issue. We're creating this because I wanted to continue my learning on the engraver, and Logan also wanted to laser engrave some objects. We'll engrave at least 1 object on each day of the launcher, and I'll get the objects that I find to engrave, let people ask me to engrave.
My technology is a Muse laser engraver. Laser engraving is a marking method that uses a high energy density laser to locally irradiate the workpiece to vaporize or change the color of the surface material and perform permanent marking. Engrave on wood, acrylic, and even paper. What is easiest to see in the code is paper is pretty easy to see, but there's no real point because printers exist. And then
I know most of this from last launcher. Yeah. Logan,
this is
Pretty
stuff I
pretty
learned.
much a clean slate. He started where I started. You know, we did the aluminum on the thumb drive cases. Yeah, it's not gonna work.
Jump topic.
Relation to the real world. The industrial laser is much larger and does more precise cutting. Other than that, the lasers are very similar and can do many different materials, designs, and styles of cuts. There's also laser pointers to use if you just want to see a laser. Our laser engraver, industrial.
What?
Laser pointer.
That's a lightsaber.
No,
I learned that the laser works with an app on the computer to control the laser. I learned that the app you can add pictures, words, and shapes. I also learned about the materials that you can engrave. I learned the different settings on the laser and like in the app. Some of those are the power, speed, the blur, the sharpness, and curves. And I didn't get the full part of the experience because we got stuck on one project. I was also not here for like 2 months.
what did I learn? I learned how the engraver can do things incorrectly with no user error. On the 4th day, we tried to finish our project, and I restarted the engraver and did the exact same thing I've been doing the whole time, and it worked. The engraver needs to restart sometimes, and I guess it hadn't been done in a while, but yeah. As soon as Mr. Ponzer touched it, it worked. Both of us tried to cut it, it worked that time.
We had a lot of issues with the launcher because the lines wouldn't cut and it was always on autofocus, leaving a charred black line around the design and not cutting. It did this every time except for the last run on the engraver.
More issues. The engraver had problems that I couldn't solve other than resetting it. After I set it to engrave, it would raise the laser too far up, resulting in that line, you know, the charred one, and not being able to cut because the laser is too dispersed at a high height. After I reset the engraver, however, I did the same thing I had been doing the past couple of days, and it worked. That reset the height and let it cut. I had interest in continuing the launcher and engraving more things, but that didn't turn out because we got stuck on one project for the whole launcher. I did learn some things about the engraver rather than its settings on the app. I did learn the settings like the focus height, which was the main issue that I had.
You know, I did this because I wanted to create Batman. That's up there. Those are also there. I don't know if they can see them or not. But through the rough drafts that we had, which is the one I took home for some reason, I don't know why. Anyways, that one did not work, and then we had those good ones. And I learned about the many different options of the engraving machine on the application, and throughout the book there's settings that you can learn how to do the different materials, and yeah.
Our result, the project we started, we decided on Batman, Google, and we did the same image for both of them. We started it because we thought it was going to be simple, but it turned out to not be simple. It's a decent result considering that it's Logan's first time on the launcher.
I think we didn't achieve, but at the same time we kind of achieved it because the engraving of what and then whatever. I would do this launcher again, and I plan. I guess Parker plans to do it next launcher. So yeah.
I would change the engraver. It didn't work well and it messed up our launcher. I like the freedom of this launcher and we didn't have much success. It was still fun. In the launcher we had our troubles, but ultimately got the first thing we wanted, but didn't complete the rest of the launcher. got Batman's?
3.
Because he's the Dark Knight. That's why he's dark.
42.
2.
Okay, let's go.
Okay, that's supposed to say holders, not holders. Phone stand and controller holders. I'll be using the technologies called Tinkercad and the 3D20. Level 2 Tinkercad prototype. My smart goal. Our challenge is to come up with your own invention or product idea. Design a draft prototype by using Tinkercad. Then evaluate your prototype, see if you can find ways to improve it. I will use Tinkercad to create some controller holders for the MetaQuest and a fold holder for my FBT. I will use the 3D20 Tinkercad and some knowledge about making stuff in order to make this happen. I will be able to do this in 4 days, such as the 3D20 and Tinkercad, to meet my goal of making the phone holders first. I will know when I meet my goal when the phone stand is printed. Attainable. I will be able to complete my SMART goal, because I have all the needed resources like the 3D20 and Tinkercad app to make what I need and my knowledge to successfully master this goal. I am creating this because I really wanted a phone stand, but to use for my full body tracking, except for not having like the time to use our own 3D printer to make this happen. Day 1, I'll make the controller holders for my MetaQuest, and day 2 and 3, the phone stand, and day 4 to print. About my technology. The tech that I'm using is called Tinkercad. It is really cool how you can make anything on Tinkercad. Tinkercad is a simplified, constructive solid geometry method of constructing models. A design is made up from primitive shapes that are either solid or whole. Combining solids and wholes together, new shapes can be created, which in turn can be assigned to property of solid or whole. My phone stand is a solid brick, and it fits my phone very well actually. My next phone stand will be adjustable for the charger as well. My phone stand and other stands can be used around the world to make it easier to watch what you're watching or play games. Here's an adjustable gear phone stand, and here's my solid brick of plastic. What did I learn? These are my controller holders. They're not the best, but okay. I will be using the 3D drawing software. It allows you to visualize your ideas before you can build or print. Imagine trying to build a skyscraper or bridge without first creating the model of it. A mistake could be made extremely expensive and potentially dangerous. Iteration means repeating a process. Most final products start with a drawing, a model, and many versions of each. By using a drawing program like Tinkercad, you save time, money, and materials. Tinkercad allows you to view your designs in 3D. You can fix mistakes and improve the design before printing. 3D printing in plastic creates a prototype to test before we build our design with more expensive materials. What problems did I have? The problems I had was getting the phone stand to fit with the phone I had.
My first print went very well, and I was very surprised at how good it turned out and how it fit. I was working on the controller stands for the MetaQuest and forgot to get them printed. Oh my goodness, I can't speak. So that'll be on my other project. My first version of the phone stand. My first version was way better than the second version, mainly because it fits the phone perfectly. And I did that was just at random, and I didn't measure my phone at all, and it turned out perfectly. I randomly drew a shape, created some holes, and everything went good. Why did I want to make a phone stand in the first place? There are a couple reasons why I wanted to make a phone stand. The main reason is because I have a game that I like to play called VR Chat. VR Chat is a game on the MetaQuest that is very nice and a cool game. VR Chat is basically like Roblox. There are thousands of worlds that you can visit and meet people. The phone stand is for my FBT, full body tracking. And I'm using the app called Viso. Viso is an app that uses FBT and sends OSC data to VR Chat for complex movements. My other problems. The problems I had while making the phone stand is time. I really wanted a long time to make this, so it could turn out pretty good. But I ended up having 4 days. The 4 days, I wanted the VR controllers to be made, but I got stuck on making the phone stand instead. That is what it turned out as in the IRL. What is full body tracking? Here are a couple pictures. Here's the app that I'm using, and here's a test sample from the app itself. With Viso FBT, you can finally immerse yourself in VR and drive your avatar's movements using your phone camera. It is completely free. Completely free. You don't even need to pay for it. No money spent for every single tracker. Viso FBT supports VR Chat on both Quest and Steam VR. It compares your movements to your entire body from your elbows to your feet. What is OSC data? Open Sound Control is a commercial protocol that is independent away from any specific transport mechanism. That said, OSC packets are the most typically sent to receive using UDP sockets. And OSC is used to open-ended dynamic URL style symbolic naming scheme. Conclusion. Okay, my challenge was to make a prototype from Tinkercad. I did achieve my SMART goal by making a phone stand in about 4 days. I would do this launcher again because I love 3D printing, and this from Tinkercad, and it was very fun doing it. The thing I liked about the launcher is that it focuses on you to make something from scratch. The main success I had was getting the phone stand done again in 4 days. The things I learned is how you can get ideas from just like around everywhere, and you can make anything at this point. But sadly, I did not have a partner to do this, like with someone. I made a phone stand from scratch and going into the process blindfolded basically, and it turned out very nice. And here's my vocab. Yes,
Is that
FBT.
1 or 2?
Does that FBT let you like break dance and stuff? If you get like full trackers, it'll do much more complex movements, but with this free version,